This is AB Calculus, section 3.9, page 3. We just learned the formula for the derivative of a natural log. Let's go ahead and just crank through some problems here then. First thing, this is the natural log of 4x squared minus 9. So when we find that derivative, y prime, the derivative is 1 over the u. So 1 over u, 1 over, silly, 4x squared minus 9 times the derivative of that u, and the derivative of 4x squared minus 9 is 8x. And again, clean this up a bit. Y prime is 8x over 4x squared minus 9. And we're done. Looking at this next one, y equals the natural log x quantity squared. Let's find the derivative. When we find the derivative here, we have a chain rule. The square is on the outside, the natural log function is on the inside. So when we do that derivative, y prime, we'll do the derivative of the square first. So 2 natural log x to the first times the derivative of the inside, so the derivative of the natural log, that's 1 over x. And then cleaning this up a bit, this is 2 natural log x all over x. And this next one, y equals x natural log x minus an x, find y prime. When you look at this, you have to see product rule right here with this x times that natural log x. Doing the derivative then, product rule, first x times the derivative of the second, 1 over x, plus the second, ln x, times the derivative of the first, which is 1, minus the derivative of this x, that's just 1. Oh, and look how pretty this turns out to be. X times 1 over x, that's 1, plus natural log x minus a 1, and we end up with the derivative is just the natural log of x. All right? Now, it's all fine and beautiful for natural logs, which is a log base e. But what about logs with other bases? For example, log base 2 of x, or log base 10 of x. And do you remember that that log base 10 is called a common log? And most of the time we don't write the base 10, we'll just write that as log x. Or in general, log base a of x. We're going to find the derivative of log base a of x. But first, I want to just kind of notate something here so that we can use it in a couple of minutes. Would you agree with me, or I'm telling you a is a constant? If a is a constant, then ln a, the natural log of a, is also a constant. As is 1 over the natural log of a, also a constant. That information will become important here in the next couple of minutes as we start working through this derivative. I want you to find the derivative of y equals log base a of x. The first thing that we're going to have to do is to use the change of base formula from pre-calc. And to change that, we're going to change it into natural logs. And this would be y equals the natural log of the argument, which is x, divided by the natural log of the base, which is a. All right, now I'm going to rewrite this. Y equals 1 over ln a times ln x. Now do a derivative. Y prime. And here's where this information came into play, or comes into play actually. This 1 over ln a is a constant, so that just comes down. 1 over ln a times, now we need the derivative of the ln x, which is 1 over x. And we'll just rearrange this a bit. This is 1 over x ln a. That's y prime, which is the derivative of, oh, I didn't write over far enough. That is the derivative of log base a of x. Expanding that in case we happen to have log base a of some other function in here, the derivative of log base a of some function u is 1 over, instead of that x, that's 1 over u times the natural log of a times the derivative of the u. There's your chain rule going on. Guess what? Yes, please memorize this. Memorize. All right, now let's do a couple of examples here. This first one, y equals log base 5 of the square root of x. I want you to find y prime. When we do this derivative then, the first thing that we'll do is rearrange this function so I don't see that square root anymore. And we have y equals log base 5 of x to the half. All right, here's the a, the 5 is the a, and this x to the half, that's the u. All right, doing this derivative, y prime is, all right, following this formula, it's 1 over u, which is x to the half, times ln a, that's the 5, times the derivative of the u, the derivative of the x to the half, 1/2 x to the negative half. And cleaning this up a bit, we are going to end here for day 2, but let me get that out of the way. And when we rewrite this back as a single fraction, we'll have a 1 here, an x to the half, that's square root x, natural log 5, this 2 is here, and this x to the negative 1/2, that's another square root x, and y prime then, cleaning this up, 1 over 2, oh, square root of x times square root of x, x, ln 5. All right? Now, there's another way to do this if you use your log rules. So completely acceptable if I start right here, y equals log base 5 of x to the half, using that leaping exponent idea from pre-calc. This half can pull down in front, so we'll have y equals 1/2 log base 5 of x. Now do a derivative, y prime, that half multiple out front, 1/2, and then the derivative of log base 5 of x. That's 1 over the u, so 1 over x times ln a, which is 5. And you can see that these two are equivalent. Whichever way makes you happiest. Either one works. All right. And the last one on this page, let's look at this one. I'm just going to draw a little squiggle line so I can keep this one separate over here. All right, plugging on through. Let's use purple. First thing I think I would do is to rewrite this equation to get rid of the quotient. Then we don't have to do a quotient rule. We'll have a pure product, chain rule actually. So y equals the log of 4x to the negative first. Now we can do a derivative, just chain rule. Y prime, the outside most is this negative 1 exponent. Pull that in front. Negative 1 log of 4x to the negative 2. So we've taken care of that negative 1. Now do the derivative of the log part. And the derivative of the log part will be 1 over the u, so 1 over 4x times ln a. ln, oh boy, what's a? A is the base of the logarithm. Since I didn't write it here, this was log base 10. Log, so natural log 10 here. And then times the derivative of the inside of the log. So times a 4. All right. Cleaning this up a bit. On the numerator, we're going to have, oh wait, just a negative 1. Did you see these 4's here? Divide out. And then we'll have x ln 10 times this log piece. That's the log of 4x squared. And that's it. All right, a couple of things just in your handwriting and the way that you express your answer. With this one, sometimes this will be written as log squared of 4x. Sometimes. And this one over here, you know, the other day I said to put the constants, so ln 10 out in front, but there's a problem if you write this ln 10 times x, somebody might read that as the ln of 10x, the quantity, and we don't want to do that. So you should avoid that ln 10 times x and actually write x ln 10. Okay, thanks for tuning in.